Okay, so we're talking about equations, and we've seen that sometimes we can have them be true or false. Let's talk about, I guess, something pretty simple. Let's say we have 2x equals 1. Okay, so this is an equation which is sometimes true and sometimes false. When is it true? Well, if 2x does equal 1, that means anything we do to 2x and do to 1 will still end up with the two sides being equal. So what do I know? Well, 1/2 times 1 is 1/2, 1/2 times 2 is 1, and x is 1/2. So this equation is sometimes true. It is sometimes false. So we call such equations conditional. Some equations, however, are never going to be true. For example, if I have an equation of the form x plus 1 equals x. This is never going to be true. If I have 5 for x, well, I get 6 equals 5. If I have 10 for x, I get 11 equals 10. An easier way to maybe see this is if this equation had been true, well then if I subtract x from both sides, whatever x is, whatever values satisfy the equation, what am I going to get? Well, I'm going to get x plus 1 minus x equals x minus x, and I'll skip the intermediate steps where I move the parentheses around, but I get 1 equals 0. So if this equation is true for some value of x, then this equation must be true. And we could sort of argue by contradiction. Say it's absurd to say this has a solution because if this does, then this is true. So this is never true. So we're going to call this inconsistent. And there are some equations that are always going to be true. For something that's really simple, I could just say x over 1 equals x, right? This is an equation that for any value I plug in, it's going to be true. Why is it true? Well, because anything divided by 1 is itself. So this is the same as writing x equals x. If I had a 1 over x, I'd have to watch out for domain issues. I don't have anything like that. It's fine. So this is always true. So we'll call this an identity, because we can always use it whenever we have a rule, like we've been calling our other rules identities at times. So, conditional equations, inconsistent equations, and identity. Next, we're going to define what we're going to call a linear equation in the upcoming video.